This is Pepe Le Pew, and this statistics lesson is on testing for population mean. But first, let's do board problem 52. In order to fairly set flat rates for an auto mechanic, a shop foreman needs to estimate the average time it takes to replace a fuel pump in a car. So how large a sample must he select if he wants to be 99% confident that the true average mean is within 15 minutes of the sample average? So assume that the standard deviation of all times is 30 minutes. Okay, so we're going to have to go ahead and use this formula right here. So this was in section 10.1-3, the video. So this is your z-score that you find for your 99% confidence, and your standard deviation is that 30 right there divided by the square root of n, and is less than or equal to my desired income, that 15 minutes. Okay, now if you look up on table C, which is in the back of my statistics books, and how you read it from table C is you look down at the bottom and you find 99% down at the bottom, and then right above it is your z-score for that. Okay, and you should see 2.576. Okay, so times 30, square root of n, and you get 26.54, and since it's greater than that, greater than or equal to, it's choice A, 27. Alrighty? Alright, so let's go ahead and begin this lesson. Testing for a population mean, section 10.2-4. Alright, here we go. Okay, so steps for a significance test, and there's a lot of writing in these next few sections. Sorry. No, I'm not. There's just lots of writing. Get used to it. So you just got to pick up a pencil, and there's just a lot of verbiage you're going to write over and over and over again, but you want to please your AP readers or your statistics professors, whatever, when you take this in college again, if you're not taking the AP test. All right, so this is what you need to write this down. Step 1, identify the population of interest and the parameter you want to draw a conclusion about. Then state the null and alternative hypothesis, or hypotheses for plural. Okay, step 2, you're going to choose the appropriate inference procedure. Verify that the conditions for using the selected procedure. So step 3, if the conditions are met, you're going to carry out your inference procedure, and then you're going to calculate either a z-score or a t-score. T-score is in the next chapter. T-score is when you don't know the standard deviations, which is most of the time, you guys, but we're doing a z-score right now because they always give us the standard deviation, or you find the p-value, okay? And we've done all of this, and you guys just need reminders. Step 4, interpret your results in words in the context of the problem. Okay, so here we go. So you have an SRS of size n, and you want to draw a conclusion about the unknown population mean, mu. Okay, so we're going to call this mu sub 0. All right, so your null hypotheses is always there's no change, so the population mu is equal to your sample mu. That's what that says right there. Okay, your alternative hypothesis, and then to standardize this, you use our old friendly old z-score conversion right there. Okay, and then if it's an alternative, if your alternative hypothesis is one-sided, if it's greater than or less than, then you do the population mean is greater than your sample mean. That's what that says right there. And then your p-scores, where you do your z-standardized conversion by using this formula right here. Okay, and then we're going to do that bell-shaped curve, and we do the 1 minus this because this is for greater than, and your table always gives you to the less. So if they ask you for less than, then you do to the left. But if they ask you for greater than, then you do to the right, and you have to do 1 minus that. Okay, and then number 3, if it's a two-sided one stating that they're just not equal, then you got to do twice your p-score right here because it's two tails right here. So you find one of them and then you double it for the other one right there. Okay, and I choose to find the negative one because my book always gives me to the left. I know some books give you the area to the right, but the book that we're using gives me the area to the left right here. Okay. Here's an example. The diastolic blood pressure for American women aged 18 to 44 has approximately the normal distribution with mean population mean of 75 millimeters of mercury, and standard deviation of 10 millimeters of mercury. Okay, and we suspect that regular exercise will lower the blood pressure. Well, I think so too. All right, so a random sample of 25 women who jog at least 5 miles per week gives a sample mean blood pressure of 71 millimeters of mercury. Okay, so is this good evidence that the mean diastolic blood pressure for the population of irregular exercisers is lower than 75 millimeters of mercury, okay? So we're going to test it at the 5% level, and we'll test it at the 99% level also, okay? So if we get a probability that's less than 5%, then it would be significant evidence. And if it's less than 1%, then it's even more significant, very strong significant evidence, okay? So, and this will make sense in a bit, you guys. So, step one, yes, write this down. Identify, you're going to be doing this on every problem now in these. So, identify the population of interest and the parameter you want to draw a conclusion about. Then state the null and alternative hypotheses. Okay, that should be an ES right there for plural hypotheses, okay? Just to have it. So, the population of interest is all American women age 18 to 44, and the parameter is the mean diastolic blood pressure. That's what we're looking for. My null hypothesis is that there's no change, that it equals the population mean equals the 75, okay? And my alternative hypothesis is that it's less than 75 because we expect that exercise is going to lower that, all right? And 71 is lower, so we're going to test that out right here. So choose the appropriate inference procedure and verify the conditions for using the selected procedure. Well, first I like to verify it first, you guys. So we're just trying to impress your AP readers, you guys, or your college professors. So try to think, even though the sample is not random, we're not sure if it is a population of interest. I'm sorry, even though the sample is random. I'm sorry, because it did say it was a random sample. We're not sure if it's, came from the population of interest, but, we're pretty sure, but we're just not sure. So this may limit our ability to generalize, okay? Now that's just good communication that you're understanding statistics, you guys. So you want to impress your readers, all right? So since the population is normal, then the sampling distribution of your sample mean will also approximately be normal, so we're safe to use the Z procedures. Okay, and we're using the Z procedures because the standard deviation is given. If the standard deviation wasn't given, that's the next chapter, we'd be using the T procedures, but we'll get to that later. All right, so assuming, so step 3, if the conditions are met, and we just said yes, then carry out the inference procedure. So assuming the joggers have the same standard deviation as the general population, which may not be realistic, again, we're trying to be impressive with our writing, then and you'll get better, you guys, trust me, you'll get better. This is brand new. Then the Z statistic is that formula right there. And then so we're going to plug in the numbers and we get negative 2.00, okay? Remember how we do this right here? Here's negative 2.00 because there's 0 right there, and we look up negative 2.00 from table A in the front of the book, and we get 0.0288, which is less than 3%, you guys. So this is significant at the 5% level because it's less than 5%, but it's not significant at the 1% level. Okay, so step 4, interpret your results in words and in context of the problem. Okay, here we go. Since the p-value is so small, there is not much of a chance of obtaining the sample like we did if your null hypothesis was equal to 75 is true. So we reject the null hypotheses and conclude that the mean diastolic, and you can say this, and we accept the alternative hypotheses if you want to say that, but you also got to say and conclude that the mean diastolic blood pressure for American women aged 18 to 44 who exercise is probably less than 75 millimeters of mercury, okay? Because the chances are that you'd get something so, a group that gave you that 71 right there, the chances are would be, less than 3%. So that's, that's pretty significant. If it's less than 3% that's going to happen, then I would say, that it's not equal to the 75. It's got to be less than 75. All right, and there's your homework.